It was done for me. I couldn't, I wasn't happy any place else but out here. And before we retired and moved out here, we'd come out here at least twice a year to observe. And like I said, we moved out here 6 years ago. And Barbara mentioned that I kind of went off the deep aperture end there and built a 1.2 meter telescope. And ever since I built that scope, it's a totally visual instrument. I don't do any imaging at all. I'm a visual astronomer, and I'm proud to say that. Not that I have anything against the people on the dark side, but another thing I like to thank Larry Mitchell, who took this photograph 3 years ago in my observatory, and that is the 48-inch scope. As y'all can see, it was quite a wonderful night we had that night. So thank you, Larry, for that beautiful image. I really treasure it. So me having a 48-inch telescope, I'm always looking for challenging objects to observe. So the Sloan survey goes pretty deep, as most of y'all know, I think down about 22nd magnitude. So I finally figured out how to navigate through the Sloan, because I'm pretty computer challenged. So I finally figured out how to master the Sloan and navigate through there, and I discovered something doing that as I moved through out toward the edges, I don't know if y'all realize it or not, but they didn't do the entire sky, they just did strips through the sky. And out on the edge of these strips, there is, as you can see, here, right there, they just stopped the survey. So I found out through many hours of as I call it right here, cruising down the Sloan Highway, that out on the edges of the survey, their computer programs that IDs galaxies and objects doesn't work all the time. So I find uncharted stuff for me to observe all the time. I'm tipping my hand here and giving y'all my...
Before I did this for a living, I did it for fun. And when I was a teenager living in Alabama, my parents were crazy enough to let me and a friend drive to Vermont to go to the Stellafane Amateur Telescope Makers Convention on our own. And had just about the best time I ever had, maybe until tonight. So, so I'm with you on this, I understand your world. And so, Jimmy, where is that? Here we go. So yeah, I've known Jimmy, I guess, pretty much since the time he got here. We've observed on the 82-inch together, and I've gone to see wonderful things. Some of the best views of galaxies I've ever seen were through the 48-inch telescope. And so when he came along with this object, I mean, it seems like every other year or so, Jimmy's coming along with some fantastic thing that he's seen, and we try to follow it up. So this was a great opportunity. We decided to look at it with the Hobby-Eberly telescope with the low-resolution spectrograph. So they pay me to live here and use this thing. Can you believe that? And so this is a picture I took one morning of the. I'd just been observing on the telescope, and I came home not observing a whole lot, as you can tell. But so this is the dome from my front yard, and so here is the Hobby-Eberly. I just stuck this in because I know a lot of you are taking tours of the telescope this week, and you probably noticed this big smokestack-looking thing with a big golf ball on the top. Big round thing. So the round thing is a room which, when the telescope is pointed at it, contains high resolution and the medium resolution spectrographs live down in the basement. So here's the control room. This is our telescope operator, Amy Westfall, one of 4 telescope operators. And they have the really hard job. They have all the screens to drive the telescope and make it go where it's supposed to go and focus up on the object. And the astronomer sits over in a chair with 2 little screens and runs the spectrographs. We have a pretty easy job. So down to the business end of things, we decided to observe the sweet pea with the low resolution spectrum. This is the sweet pea, by the way, has a gun G magnitude in the gun G photometric system of about 17.9, almost 18th magnitude. And the gun G is sort of like a B magnitude, it's close to there. So pretty faint. This is a 1 second integration on the AGT of the green pea. Oh, I let the story out of the bag. And this is what we call the pre-image. The low-resolution spectrograph is what's called an imaging spectrograph. You can take pictures with it, and you can take spectra with it. And the way we set up an observation is first we take a picture on the sky, because we want to see the object that we're going to observe spectroscopically. Night sky emission lines. Those are lines that are created by molecules in the upper part of our atmosphere. Those molecules are excited and they emit spectral lines. So you see those all the way across, because every part of the slit, basically each spectral line is an image of the slit at a certain wavelength. Okay, and this is a very famous. This is called the 5577 auroral line. This is a very bright line that is very prominent when you see auroral displays in the north. So this is the primary line in the Balmer series of hydrogen. But not only that, see how it's fatter and sort of squatter than the other lines? It's actually, unfortunately, it's what we call a blend. There are also 2 nitrogen lines. Well, he's using a more classical set of R, G, and B filters, right? So the green is somewhere around 5,000 angstroms. The red is around 6,000 angstroms. So that booming H alpha plus N2 line, that's sitting right in the middle of the red filter. So that's why you get that red color in atom blocks image. But I puzzled on that for a while. That's a good question. But thank goodness it does look green in the Sloan, because that's what drew Jimmy. That's one of the things that drew Jimmy's attention to it.
Really. Next question. Mike.
One of the few things that seems like is an established fact on this is that the first thing that happened with it was misidentified as stellar.
Right.
And I'm wondering, has there been any thought to searching maybe other high galactic latitude regions in the Sloan survey for other items which might have been originally identified as stellar?
That's as high as they went.
Oh, you repeat.
What he wanted to know was, can you...
Debbie?
I was wondering how common are difficult to classify objects?
Debbie, louder, please.
How common are difficult to classify objects?
How common are misclassified objects?
I could be the perfect person on the planet to answer that, because for the first 10 years or so after grad school, I got paid for doing that, or teaching computers how to do that. And so I would say it's really hard. So I mean, I deserved every penny I got for it. But no, it usually it's sometimes it just depends on the faintness of the thing. If an object is extremely faint, even on a deep image, a well-exposed image, it's very difficult sometimes to even tell the difference between a star and a galaxy. They took seeing that was under maybe they accepted data under a little bit worse seeing than they normally do, or whatever. And it's difficult. And if the sweet pea is a planetary nebula, and it is at 22 kiloparsecs, it has a very small extent on the sky, and so it might be difficult to, I mean, I wrote many of these pipelines that do this star-galaxy separation for other projects, so my heart goes out to the Sloan people. So they screwed up, But actually, Jimmy didn't say, but now in Data Release 8, they fixed their software, and now it's classified as a galaxy, i.e. extended. So sometimes it's hard, sometimes it's easy. Bob.
But what does that tell you? What does that lead you to?
It'll give us a better measurement of the flux, the amount of energy that's coming out in that hydrogen line alone. And it will also tell us an important thing for planetary nebula is the ratio between the strength of that nitrogen line, the one on the red side, and the hydrogen line. That will tell us something about the abundance of the nitrogen and the excitation of that. So it will be important to learn something about the gas if it's a planetary nebula.
Impressive list of people that have received this award. It says Lone Stargazer Award, I can't hardly talk, presented to Jimmy Lowrey for accomplishments and dedication in advance Deep Sky Observing, Texas Star Party 2011. Oh, thank y'all so much. I am totally honored.